Hello, internets. Now, recently I've discovered a phenomenon on YouTube of this thing called Electroshock Jenga, where people have gotten together and kind of wired each other up with either one of these electrical pulse massagers or a actual dog shock collar. And they play it where you play in your Jenga, and someone, when they go to touch it, you got a buddy that triggers the buttons, shocks them. Now, this is all fun and everything, but I decided it could use some improvements because playing that, you're really at the mercy of whoever is at this controller. And, you know, that might be fun, maybe, but just doesn't really satisfy the mad scientist in me, and it doesn't fit the cruel, you know, reality of electrical shocks that you're getting and the vibe it's bringing to this game. So I decided to improve upon the idea a bit and develop a version of this called Automatic Shock Jenga. Now, as you can see, we now have a scary yellow box and Jenga blocks that look like a chimney sweep. And what this allows us to do is play the game such that it detects when we touch the Jenga stack and initiate the electrical shock based on that. So we've got our normal little controller here. This one, $30 on Amazon. And it gives us two independent ports so you can customize the shock to each player. I see I'm wired up on both players because I try to get my family into this so they see this box and the warning labels, whatnot. They're not really having it. Now, I'm going to set it to something works. You know, this is this tap mode. Boop. This just gives you a little love tap when you go to touch the Jenga stack. So, let me switch player. Here we go. Got our sign, touch to begin, player one. Normal mode. This is our capacitance reading. This tells us if we're touching the stack or not. I'm gonna set that to 0. And we touch it, we get a countdown, 3 seconds. And now whenever I go to touch it, let's turn this down a little bit. Maybe make it actually doable. We get a little shock. And that makes it very difficult. So, you know, probably what you want to do is set this timer up a little bit, maybe like 6 seconds or something. So we switched the rocker switch. We're on to the other player. Oh, okay, I gotta count up. Fuck. Oh no. See, I'm getting a little tap here. I can use the other hand to test it. So we really crank this up. Is this on? This is and if you really crank it up to the maximum, you know, it can be hard. You can really hang in there. You be steady. Maybe. Okay, there you go. Hit the button. You're on another player. It's kind of like a chess game or chess clock, where you whack it, get a countdown, and oh, okay. And that's normal mode. We got a couple different modes. You know, the other mode is sudden death mode, which is once the timer happens, you are committed, and you will be getting shocks until you tap out here. So that's you know, different styles of play, and give a demonstration of what this thing can really do. Crank it up on this different setting. 6 seconds on the clock. I'm gonna touch it, trying to get my block out. And oh. Ow. Okay. That might be a little much. Whoa. Okay. Let's. Right now I'm getting the shock's so powerful it's bleeding through to the other side. And switch mode. Okay, now we're back to normal. Give an idea of like you know, obviously, whoa. Ah. Oh. So, lesson learned, if you crank this up right now, it goes straight through the electrical relays that we're using in here. Okay. A little demo of, right. That's what you're waiting for, right? I'll give you a little technical rundown of how this thing works, kind of the principles, and then also how I've implemented it. Now, with our box here, kind of we got these timer switches to determine, you know, how long that countdown is, and then we have, these are sensitivity S, that's the threshold, because it varies the capacitance number, which is here, depending on your Jenga stack, how sensitive you need it to be, because the thing with this way this detects is that even along this cable or something like that, it can detect capacitance change. So you just want to have it at just the right threshold. We got to zero it out. That lets us, once we get it all set up, everything's got a baseline capacitance to work with. So we can zero that out here, and then we got our game mode. So there's the normal mode, and there's the sudden death lunatic mode. Now, the whole thing that makes this work is that my understanding is capacitance sensing, it's kind of it's pumping voltage into whatever this lead is connected to, and I think it's measuring how long it takes for the voltage to build up. I mean, that's my understanding, because you know, capacitance is detecting how much charge something can hold, so we're sending charge in, or seeing how long that voltage takes to build up. And that requires a certain amount of conductivity on these electrical blocks. Now, you know, this can easily detect when you are touching it, because, you know, there's a certain amount of surface conductivity in your skin. It's, you know, moist and everything, but a normal wood block just isn't necessarily that conductive. And I was testing this out. If we just had these bare Jenga blocks and we had them on here, you know, the first block, it would be at about like a 10 or something, and it just wouldn't work if we do the whole stack. So what we've done is coat these with straight graphite powder. Graphite powder is quite conductive, and these ones, you know, I just kind of brushed it on here, and it really makes a big mess, but it works. But I do have other blocks that I actually is this one of them? I think so. Mixed them with a bit of this wood stain, and that really holds things together and keeps from making a giant mess when you are using the blocks. Now, just to give you an idea of what's going on here with these guys, get the fluke out here. Boop, boop, boop. And read on these, that's like 8 mega ohms. I mean, it's like pretty high resistance, but it's enough that it just barely squeaks by to work with this setup. Now, inside this magic box, we are running a just pretty straightforward Arduino setup. This is a Arduino Leonardo. No particular reason. I just have one laying around. You can pretty much use anything. We've got one of these Sane Smart relay modules. This is a nice rocker switch from Home Depot. This is your like Amazon, eBay knockoff LCD display with this nice little I2C backpack. Makes working with it really easy. And got a little button array. That's all just pretty standard, just reading right into these ports. You know, this is all the ultra rapid fabrication methods for this setup. And you know, it's not easiest to see, but you know, we got, this is the capacitance lead wire coming into, it's actually leading off the analog port, because we're able to get this library that just needs one port. It's pretty cool to read capacitance on. And that's pretty straightforward. Programming this guy, it's It's just kind of a state logic setup, just a bunch of kind of if statements or whatever for running this game logic. It's not super complicated. I got the sketch linked in there on the GitHub. You know, it's quite straightforward. And what is very important is that you know, we got our sensor readings coming in our microcontroller, just reading it, getting the threshold. I initially thought going into this that, oh, I'll make the circuit to give out the electrical shocks, but I think that's actually a very bad idea. And this is only $30 on eBay. It's or Amazon. You know, it's actually like certified by a U.S. company. It's not going to kill you. I tried to pop it open, look inside, you know, oh, is there just, you know, the actual shock generator that I can just integrate in there? Because, you know, it'd be nice to have full control over your waveform when you shock, and you can really customize and everything, but it's a little bit above my pay grade. And I noticed there was some open source projects to open EMS to, like, you know, have your phone control shock stuff like this, but they were using a like FDA cleared stem generator. So if you do this, yeah, you get one of these. If you try to make your own circuit, you know, good way to kill yourself. The way this is being controlled is kind of a jumble of wires here, but we've actually just got one lead per side coming in, running through the relay, and that just... Now, it was very interesting, I saw when I really cranked up the power. You can see these relays, you know, they're like, this is a little speaker here. They're like, you know, 120, 220 volt rated. And when I really cranked up the power, this thing was just, voltage is just bleeding through here. I don't know what voltage this runs at, but when you really turn it up, yeah, it's a lot. So, you know, there's totally the danger that all that junk will get back through here and smoke your board. You know, there's these opto isolators here, but, you know, if it's like 300, 400, whatever volts, you know, is that really going to work? I got no idea. Another important thing with this setup is that we have to have a conductive base to work with our Jenga. Aluminum foil totally works great. You know, it's not the prettiest setup. You could build something that looks nice, but this is just grab it on here and stack your blocks. You're ready to go.